My name is Liz City. I'm Executive Director of the Doctor of Education Leadership Program at the Harvard Graduate School of Education, where I'm also a lecturer on education. When you've collected all of your data, you're facing a large pile of data. Sometimes it's hard to know how to dive in and how to analyze those data. One of the things that I've found very helpful in my work is using protocols or structured-based conversations, especially when you're talking about data with other people, which is really the best way to talk about data, is to do it with other people. They'll see things you don't see. You'll collectively decide what to do next. But the thing is, you have very limited time in school. You may have 45 minutes for your common planning time, and you need to figure out how to efficiently use your time to look at data and get somewhere with it. So different sorts of protocols can be very helpful, even if it's as simple as, we're going to start with, what do you see in these data? To slow yourself down from everybody leaping to conclusions and deciding what to do about the data, which is something we educators often do. We want to do something for kids. We want to very quickly leap to something that's going to be helpful for students. So we go from data to solution in 5 minutes. Well, that's not very helpful because you've skipped the whole inquire part of the data cycle. You've skipped saying, why do the data look these way? What are we seeing here? What do you notice? So often we use protocols that start with a what do you see? What do you notice? What kinds of questions do you have as you look at these data? What other data might we want to explore to dig into these questions some? And what are our next steps based on what we're seeing in these data? So something very simple like that can be helpful for looking at data. Another thing that can be helpful is before you sit down in your collaborative team meeting with those data, if somebody has processed the data a little bit, especially if there's number data, interim or standardized test data, can you move the data from charts and numbers to try to make pictures out of the data? That will also help us be more efficient. If we're looking at a bar graph, instead of trying to look at lines and lines of numbers, can we just look at the picture to try to see, oh, what's the storyline here? Whenever you're looking at data, you're trying to figure out, what do I see? What are the patterns? What's the storyline? What are these data telling me? And now what do I want to know? So that's really a strategy for using data. It's not too fancy. You don't need fancy programs necessarily. They can be helpful, but really just sitting down with those kinds of questions can help you work through data quite efficiently. Whenever you're looking at data, you want to ask the question, why? You also want to think about using data like you're a scientist, which for those of us like myself who were English teachers doesn't come naturally. But you want to think about it like a scientist. You're presented with something and you want to ask why. Why do the data look this way? So you might say testable hypotheses, but what you're really trying to figure out is why. So when you look at a set of data, you're going to ask the question why. A very popular protocol that comes out of the business sector is to ask why 5 times. You ask it once, why did the data look this way? And then you say, we have an answer. Why is that true? So I'll give you an example. We're struggling with students drawing inference when they're reading, a very common problem in many schools. So why are students struggling to draw inference? Well, we're not sure we're explicitly teaching inference. Okay, why? Why aren't we teaching inference? Well, we're not sure we share a common definition of what inference is. Why don't we share a common definition of what inference is? Well, we haven't really done professional development on inference. We've been really focused on comprehension, but we think inference might be different. All right, why haven't we done professional development on inference? Because we haven't allocated our time to that. And maybe if we focused on that, we could allocate our professional development time to it. So if you ask these 5 whys, you stop when you get to something actionable. A couple of other characteristics of testable hypotheses are, one, that they're testable, that you could figure out what data would I look at to try to answer this question, to see if we're right about this hypothesis. So I'll give you an example. It was in a district in Iowa not too long ago, and they were struggling with transfer. They said, you know what, students aren't transferring their knowledge from class to class within the same grade or from grade to grade. They know something in 5th grade, and then they go to 6th grade, and it's like they were never taught it, something many of us have experienced as teachers. So they said, why are students struggling with inference? What are our hypotheses? And they said, well, we think it might be because we're not really giving them high-level tasks. And we think we're maybe not giving them enough opportunity to apply those tasks. And we think that maybe we're doing all the work, that we're up there teaching our brains out and students are just sitting there. So let's see if we can test those hypotheses. They then made a theory that said, if we taught students and had them do the work, if we gave them opportunities for application and if we gave them high-level tasks, then we think they would transfer. One of the things that's helpful with testable hypotheses is that you have some kind of theory about how you think the learning should be working that you're tying back to. In this example in Iowa, they had that theory coming out of their own experience and also the literature. They went and read about transfer. What do we know about transfer? What does the brain research say about how transfer works? And then they narrowed down their list of hypotheses to those 3 and then observed in classrooms to test their hypotheses.